Right, so this is attempt number 3 at recording this video. So, just turn the heater off, it's noisy. The action potential. So, because I've tried to record this 3 times, everything's already written out, so I'm just going to talk through it. So, the action, mind, I should bloody well know it by the end of this, if anything else. So, the action potential. So we've got our graph. So if our exam question says explain how the action potential comes about, best thing is to draw the graph and then talk through it. So this is our graph with time across the bottom axis, and then on the other axis, this is voltage in millivolts. So we've got along here in this orange line what is called our resting state, our resting membrane potential. Okay, this is approximately minus 70 millivolts. So, as we can see, I'll point with my finger rather than a pen, it's more accurate. Our resting potential is about minus 70 millivolts, right? So this is this red line here. So a stimulus comes in. Stimulus comes in and the cell gets excited. So what happens when the cell gets excited is sodium channels open. Sodium. And there is an influx of sodium. Okay. So what does the influx of sodium do? It makes the cell less negatively charged. So we can see, back to pointing with a pen, we can see here, because I'm not left-handed, you see, our graph goes up. This is our voltage, so it's becoming less negatively charged. It's coming up. And there you can see we've got this blue line here, and this is our threshold, which is approximately minus 55 millivolts. So once the voltage of the cell reaches about minus 55 millivolts, it hits the threshold. Once it hits that threshold, an action potential is inevitable. Nothing's going to stop it, right? It's going to go boom. So we've got our sodium coming in. We've got our voltage in our cell becoming less negatively charged. And this is a process called depolarization. The cell depolarizes until we reach plus 40 millivolts, right? This is our action potential. We have reached our action potential. Now at that point, what happens next? We've reached our action potential. Potassium channels now open. Potassium channels open and potassium leaves the cell. And this particular process is called repolarization. So potassium leaves the cell and the cell becomes more negatively charged again in a process called repolarization. Now it gets back down to the resting state and then it overshoots it. And this is called hyperpolarization, okay? So whoop, overshoots the resting state and then whoop, jiggles itself around, evens itself out, comes back to resting state. So this part here is called hyperpolarization. And in this area, we've got what's called the refractory period. So in the refractory period, another action potential is not possible. But I'm going to expand on that a touch because maybe it is. So, once we've got back to our resting state, we've got back to minus 70 millivolts. That's back to our resting membrane potential, and then we're ready. We're ready for another stimulus. We're ready to get onto that next action potential. Okay, so that's it in a nutshell. So refractory periods, we've got two doodahs here. We've got an absolute refractory period, where another action potential is not possible. Absolutely not possible. And then we've got what's called a relative refractory period. And in a relative refractory period, another action potential is possible. Magic. However, it's going to take a larger amount of stimulus for that to occur. Okay, so let's write that down because we can. So we've got an absolute and relative. So in an absolute refractory period, another action potential not possible. Okay. And then what do we say in a relative refractory period? Another, help if that was actually in view of the camera. Another action potential is possible, but what? But you need a larger amount of stimulus. More stimulus required. Okay, so that's that. So we're just going to run through this again. So this graph again, let's just do. So I put some bullet points down. So you can see the graph, good. Right, so what happens? Whoop, there we go. So our resting potential, minus 70 millivolts. Stimulus occurs, the cell gets excited. Sodium channels open, influx of sodium into the cell. Depolarization, so it's becoming less negatively charged. An action potential occurs. Move the camera. You've got your action potential. Once the, oh God, having a mare. Right, once the action potential occurs, potassium channels open. So potassium leaves the cell, and that is, oh bollocks, I've missed out repolarization there. Whoops. Hang on, let's stick that in, can't have that. Let's stick it in red just to make sure. Repolarization. Can't have that. It's kind of the important bit. So, potassium channels open. Potassium leaves the cell. Repolarization, it becomes more negatively charged again. Then we have hyperpolarization. Oh, I've not got enough hands. Yeah, hyperpolarization and the refractory period. And then the voltage returns to its resting state, ready for another action potential. Boom. A bit long-winded, but fuck it.